Any of the SKAARHOJ designs you would like to put together has a bill of materials, and that is in a big spreadsheet you can find on our website. It's called SKAARHOJ_BOM, found on GitHub. And there's another video demonstrating how you should do that. But just to quickly recap what to do with the BI8 board we are going to assemble right now, we find the BI8 1x8 slim version, in other words, this column, and it would be a big help to split the screen like you see me doing right now, because that means I can see the components over here while scrolling down the list. And each time you see some sort of, like this, it says 1, yes, I need one PCB of this type. And then if you scroll down the list, you can see that I need some capacitors here, 10 microfarad and 100 nanofarad, etc. And I have found all those components already, so we can get started soldering this board. And this is what I'm going to show you right now. I prefer to start out with the ICs actually. So it can be either one, but let's just take the MCP 23017, and you need to orient it correctly, of course, like this. More or less. Okay, and in this video I'm going to show you how you can solder it without using flux. We don't really know what we think about using flux with these ICs, because it has created some problems for us and we have had difficulties cleaning the boards, etc. So we actually like to use just plain solder and then use some solder wick to remove the additional solder. But you'll also be a bit surprised to see how you can actually solder these kinds of devices, because it turns out, as you will witness now, that I'm actually just putting a large portion of solder in this corner here, and then I'm adjusting the chip like this, maybe a little bit more. Basically, I'm trying to align it so it's nicely aligned with the pads on the board. So to check this, I have a little magnifying glass I can use like this. And I can see that it was moved a little bit too far up. And today my cameraman is using my magnifying glass here, so I have to do without. Okay, so I think this looks fine. Sometimes these magnifying glasses are useful to also take apart like this, because it allows me to watch from the sides like this. Okay, so I'm happy with the position of the IC right now. Basically what I do is I put some more solder here to make sure that it stays fixed, and over here. And now that this is done, okay, so maybe now you think this is gonna give me some problems because everything is shortcutted, but I'll show you why it's not a problem in a moment. Okay, so now comes the magic. I have this solder wick here, and essentially this is gonna, it's working like a biscuit in your mouth or flour in your mouth. It's just taking all the wet stuff away from you. And this is exactly what happens if you use solder wick. So take a look at this. It's gonna be cool. Voila. And I take some clean part for it. Like that. So we go to the other side, do exactly the same. The only problem of showing this is that you may not enjoy the kind of respect you get from people when you tell them that you soldered these SMD components yourself, and they don't really understand how easy it can be. So, but now I'm showing you because I want to encourage you to try this yourself. It's a lot of fun. All right. And I think this looks fine as well. But there's absolutely no substitute for checking this with a magnifying glass, and do it in the proper lighting. Do it from one side, the other side, etc., to make sure you have no connections that shouldn't be there. So basically you are going to do the same thing for the remaining components, starting out with this little chip right here. Is connecting them, the pins. Basically, this is what you'll see with the magnifying glass. So it's just my experience that it can be a good idea to do this before. Okay, for all other components like the capacitors, the resistors, etc., I do use a little bit of flux, and those are the components that I'm going to place now. So I take the capacitors, the 100 nanofarad, the capacitors right here, and I have the microfarad capacitor down here. And since we have two solder jumpers here to solder anyway, I usually put quite a bit of solder anyway around that position. Then of course we have the tiny resistor array, and I also use a little bit of flux for that, but I definitely also use some solder wick to make sure that there's no currents running between the no connections between the pins. Generally I'm a bit dislike for with these resistor arrays. On paper they are really great, but I find that quite often or far too often I've had problems soldering them and getting good connections. Sometimes there just seem to be some problems with them, which is difficult to handle in a hand soldering environment, but we still use them for convenience and space so far. And all these things must be checked with the magnifying glass, of course. If they're okay, that seems to be the case. Okay, so even though I don't have, or what I actually miss right now on this particular board is all the resistors for the individual buttons. I also need to put a little dip switch. And normally we use a 3-position dip switch like this one. On these boards, the slim boards, it's only a 2-position, but actually there are solder jumpers. So if you know exactly what address your board should have, it's cheaper to just put a solder jumper for these positions. But the final step that is absolutely necessary before we can connect it to the computer is the header for the IDC cable. So I'm just gonna solder this quite quickly. So finally we are ready to see if this board will respond to our commands. We will not know if all the buttons are reflecting the right colors, but what we can do is to try and communicate with the MCP 23017 chip on the board, and that at least will indicate if we have done something right. And therefore we now take the Arduino and the programming cable for the Arduino, which we can only actually use if we go through the mess of putting this programming header here in the front, so I'm gonna do that. Maybe you can remember from the previous video what that was all about. And I like to just mount this so you can see what is going on. So you can load the sketch BI8 burn-in test, select the correct board, the Ethernet board, upload the sketch, select the right USB port. It's uploading, and in a moment we can also start the serial monitor. Okay. Now, when you start the serial monitor, what you see is this information. It tells us that now no boards are present, so there's no chips to communicate with. Now, the thing is, when we connect this board, and normally the best thing is to do it without power, so I disconnected the Arduino board, then I connect this one, make sure that pin number 1 is at pin number 1 on the board, and then plug this one in again. And then you enable the serial monitor, and the serial monitor will analyze which BI8 boards are connected, and it turns out that board number 0 is present. Okay, so to wrap this up, we have soldered all the essential components. All that remains now is to put the LP11 type buttons on the board and solder the necessary resistors for these LEDs in the buttons onto the board as well. And we have a BI8 board, we have a shield connected to the Arduino, and I think that's all you need to know to get started with your do-it-yourself product based on our designs.